all the techniques and approaches that we have designed in order to tackle the e-buses charging location problem have been implemented using the Java programming language. And in this Java project named e-buses charging location that you can see on the screen right now is all the source code that we have developed. We can see here the structure of the project, which consists in 7 different modules that divide or organize logically our code depending on the technique that we are using to solve the problem. So we approach the problem using 3 different techniques. We have the mixed integer programming model, which is an exact method to find the optimal solution to the problem. We have our iterated local search meta heuristic that tries to find a good approximation to the optimal solution. And we have a greedy heuristic algorithm that we use to find initial solutions that are not good, but that allow us basically to start our iterated local search. Okay, there are 2 models or 2 packages that are common to the 3 techniques that we use. One is the core package and the other one is the utils. So on the one hand, the utils package will provide complementary but not essential functionality for the 3 techniques. So things like a feasibility checker for the solutions that we are going to get. Also a printer that would give us human readable formats for our solutions, and various tools that allow us things like converting measurement physical units or rounding numbers. On the other hand, the core package contains essential functionality to execute the different techniques that we are using. So the executor class will do 2 things essentially. Will read read a file that contains all the parameters that are required in order to solve a particular instance of the problem, and the instance class will build that instance and will store that instance that is solved at any particular execution of this computer program. The executor class is our main class, and we will give details in this video about how to execute this program with a set of experiments. Now let's talk about the exclusive packages for each technique. So let's start with the mixed integer programming technique. For that we use the module class in the same core package. And I want to remark here that we implement our mixed integer programming technique using the Java API of Cplex, the IBM technology, and therefore this module class will build a mixed integer programming model using Cplex by combining and recombining all these sets of constraints that are listed here in this model implementations package, and as I said, each of one of these classes we're going to match a set or a single constraint of our model. So for example, if you go to your Wp4 D1 deliverable, the constraint 3.11 is going to be implemented here in this particular class, and if you open it, you are going to see simple code that implement that particular constraint. Moreover, the constraints in model implementations rely on variables, of course, which are in this package variables, and different sets of variables are going to be represented in each of these Java classes. Lastly, about the mixed integer programming model, we implement a strategy design pattern so that the model class doesn't need to interact directly with these model implementations, but instead with a smaller subset of interfaces that abstract all the constraints. Finally, the organization of the code for the other techniques is much simpler. We are going to have this package heuristics for all the iterated local search technique. Different classes here implement the different operators and data structures that we use. And for the greedy heuristic algorithm, the same. We have different strategies that we use for generating slightly different solutions. Now, besides the eBuses charging location Java project, we have these two fundamental directories. The vehicle routing problem is a Python project that allows us to generate the instance that later are consumed by the eBuses charging location as an input, and the data that contains both input and output data that is both required and generated. So inside the data directory, we are going to have multiple directories which represent different instances to our problem. In this case, we can see here different cities with different parameters basically, and if we go inside one of these datasets, we are going to find again different datasets, in this case JSON files that have different parameters that we will provide when we want to execute a specific experiment. Also, there are CSV files that have the distances between the stations and a list of stations with an assigned ID that later we use. Now we are going to focus on these experiment parameter files, which is the direct input to the Java project. So the first line here corresponds to one of the directories that we just see in the data directory, which of course contains different datasets. Then the second line is the execution time that we are going to give either to simplex execution or to a local iterated execution that we will change, putting here the word heuristic. Next thing is the capacity of the battery. In this case is in watts hour. Just to mention here that if you add an additional capacity of battery, or you add something with a comma in any of these lines, what's going to happen is that you are going to execute in sequence different experiments with each of these parameters. In line 5 we have the speed of the buses. This is a default speed. Not the buses is not always going to travel at this speed, but it's normally will travel at this speed in our model. Then we have in 6 and 7, these are parameters of the generation of our instances. So these parameters are not translated in the model, but it's just which dataset is the one that we are reading at the moment of reading the instance. Then in line 8 you have the maximum delta time. This is about the disruptions of the timetables. In our model we know it as mu, the Greek letter. And then in lines 9, 10, 11 and 12, these are just flags that indicate if we are adding or not a specific subset of constraints. I'm not going into details, but here there are constraints about if we are using the robust model or not. Then in 13 we have the minimum charging time of a particular charging event of a bus. This is in seconds. Now we have the objective that we are optimizing. Usually we will optimize number of charges, but also we can optimize disruption times or number of charging events, or cost of the total system and things like that. Then in 15 we have the number of threads that Cplex is going to use if we chose in line number 3, if we chose Cplex, he can do multi-threading there. Then in 16 is the minimum capacity of the battery that needs to be maintained during the operation of a bus. Number 16 is the security margin that we use between chargers for giving the drivers to have time to set up a charging event. Now we have the charging rate. In this case is in meters per minute. This is the amount of power that a bus can get in a minute. Number 19 is again a flag, basically to give Cplex the possibility of a start from an initial solution or not. And number 20 is going to indicate how many chargers we can install in each location. Now, inside this eBus charging location directory, we are going to find this executable file that is going to build the class path that we need to provide to Java so that it can use the Cplex functionality, and of course it's going to compile Java source code and execute it for us. This executable is going to receive one parameter, which is the file that I just showed to you. So if we want to execute the software, we can open a terminal here in the eBus charging location directory, and then we can execute the executable file .sh, and then provide as a first parameter the file that I have told you about, and just run. So once the execution is over, we can go back to the data directory, and here you are going to find different kinds of outputs. Usually the one that starts with Cplex is like the main output. If we open it, we can see just information about the instance, a number of buses that in this case is reduced only to 10 buses. Then you have the different stations that were selected for installing charging station, how many were installed. In this case the station number 119 had 2 chargers installed there, and that's it. Then some feasibility checking procedures, and as I said, further outputs you can find in the data directory with more details about the solution.